Chapter 3, Section 1. The question we are going to answer is how can you write and evaluate or answer an expression that represents a real-life problem. Here are some notes you have to take. First of all, an algebraic expression is an expression that may contain numbers, operations, and one or more symbols. Parts of an algebraic expression are called terms. Now here are some terms. A symbol that represents one or more numbers is a variable, right here. A symbol of some kind. This is also a symbol. The numerical factor of a term that contains a variable is a coefficient. The coefficient tells you to multiply. The coefficient tells you to multiply the variable. It goes along with the variable. It's also always in front of the variable. A term without a variable is called a constant. That number's not going to change in your expression. It's just not. All right, so if you would take these notes and come back when you're done. Example 1. First, let's look at the study tip. A variable by itself has a coefficient of 1. So the term y in example 1b has a coefficient of 1. Let's take a look at example 1. Letter A, 5x plus 13. In this one, all they want you to do is identify the terms, coefficient, constants in each of the, terms, coefficients, and constants. The terms are 5x, right here, that's a term, and 13. Okay, this is an operation, so we don't want to do anything with that. So it's 5x and 13. Then we have to decide which is the coefficient and which is the constant. Well, the coefficient we had determined goes with the variable. The x is a variable because we don't know what x is. That's our variable. Our variable could change. It could be any number we give it, based on the problem, of course. But 5 depends on whatever that variable is. So it's 5x. So our coefficient is 5. Our constant, the number that doesn't change, you could add 13, you could subtract 13, you could multiply times 13, but that 13 does not change. That's our constant. Let's look at B. It says 2z to the second power plus y plus 3. What are your terms? 2z to the second power, it's your first term. Now this is what they were talking about in the study tip. Here's y. It says y. You must put a 1 there when you're identifying it. 1y. When we're doing something like this, put 1y. And then 3. You do not put the operation signs in there, the addition signs. My coefficient is 2. The second power goes with the variable. It does not go with the 2. So the coefficient is 2. Another coefficient is 1. Y cannot just sit by itself when you're trying to identify coefficients. So it has to be the 1. I will look for both if you're answering these questions. And the constant is 3. Please do the on your own 1 through 3. Show your answers. Show your, in this case you don't have to show your work, you just have to list them out. And come back when you're done. In example 2, you are writing an expression using exponents. So you have d times d times d times d. Read it left to right. Because d is used as a factor 4 times, its exponent is 4. So d times d times d times d equals d to the 4th power. It is not d times 4. Okay? That, in this case, it's d multiplied by d, multiplied by another d, multiplied by another d. So d to the 4th power tells you to list all those d's out. All right? B, 1.5 times h times h times h. Because h is used as a factor 3 times, its exponent is 3. So now in our new answer, it is 1.5, and notice when you put the number next to the variable, you don't have to put multiply or times, it's an automatic. If I put that h next to it, that means it's going to be multiplied. 1.5 ends up being our coefficient. And then h to the third power. Go ahead and do the on your own. Numbers 4 and 5, there's no work to show other than just giving the answers, and come back when you're done. Example 3, let's look at the study tip. It says you can write the product of 4 and n in several ways. Again, product means multiplication, or the answer to a multiplication problem. 4 times n can be written like this, it can be written like this, and it can be written like this. 3 different ways to do it, and it all says the same thing. So it says evaluate k plus 10 when k equals 25. So they're giving you the value of the variable. So k plus 10 is like saying 25 plus 10. And the answer is 35. You're substituting 25 for k because it tells you to do that. B, evaluate or answer 4 times n when n is 12. 4 times n equals 4 times 12, which is 48. I substituted 12 for n. Go ahead and do the on your own. Show your work, and it's numbers 6 through 7. Come back when you're done. All right, example 4, evaluating an expression with 2 variables. Evaluate a divided by b when a equals 16 and b equals 2/3. So here you're substituting numbers in an algebraic expression. This is your algebraic expression, is right here, a divided by b. Once they give you numbers, you can put it into a numerical expression. Once you have that, you go ahead and do exactly what you did in chapter 2. You're going to put 16 over 1. Then you're going to change it to multiplication, do the reciprocal, and then multiply it out and turn it into a whole number. Do the on your own, numbers 8 through 11. Show your work. Remember all the steps you did in chapter 2. I want to see all those steps. Come back when you're done. Example 5, evaluating expressions with 2 operations. It says to evaluate 3x minus 14 when x equals 5. So here you are, 3x minus 14. X is 5. Notice they did 3 with 5 in parentheses. They did not do 3 with 5 next to it because that's number 35. Minus 14. So they figured out in step 2, they wrote 3 times 5, the answer is 15, minus 14. Do the actual subtraction then. Step 3 is right here. That's your answer. Now it says evaluate z to the second power plus 8.5 when z equals 2. Wrote out the expression, put in the numbers, 2 to the second power plus 8.5. Figured this out first, your exponents, which is 4. 2 times 2 plus 8.5. Once you do it, your answer is 12.5. Please do the on your own, numbers 12 through 15. Show your work. And come back when you're done. Example 6, let's look at the real life application. You are saving money to buy a skateboard. You begin with $45 and you save $3 each week. The expression 45 plus 3W, and in this case they mean $3 a week, gives you the amount of money you will save in however many amounts of weeks you have. How much will you have after 4 weeks? 10 weeks? and 20 weeks. After the 20 weeks, can you buy the skateboard? And explain. So there's two parts of this. First, they ask you to list out 4 weeks, 10 weeks, and 20 weeks. Then, once you figure them all out, they'll ask if you had enough money. So let's take a look at the answer to A. Notice they set up a chart. The number of weeks is W. We don't know it, but we're being given that information right here in the question. So we take 45. You always start with that because it told you had $45. You add the $3 times 4 weeks. Amount saved, you write it out. Start again, 10 weeks. $45 plus $3 times 10 weeks. Here you are again. 20 weeks. 45 plus 3 times 20 is 105. So the question is, after 20 weeks, do you have enough money? No, you do not have enough money because the skateboard is $125. But when you're asked to list these out, a chart is always the easiest way to go with this. All right, please do on your own, number 16, and I'll see you in class tomorrow.